Okay, looks good. All right, awesome. Welcome, everyone. I'd like to introduce our speaker, Nailah Mims from Voatz. Nailah Mims is a cybersecurity engineer at Voatz, where she analyzes threats to mobile voting platforms and conducts internal security and risk assessments. Nailah has more than 18 years of experience that includes work in the Department of Defense, private sector, and academia. She has a computer engineering degree from Auburn University and a Master of Science in Computer Systems Management, Information Assurance from the University of Maryland University College. She served as an officer of the United States Air Force and has worked in multiple security analyst roles where she identified and responded to malicious cyber activity, deployed security tools, performed vulnerability scanning, and coordinated remediation efforts. Nailah is a certified ethical hacker and certified information system security professional. Welcome, Nailah.
Thank you, and welcome everyone. So I am going to switch to share my screen. Okay, so welcome everyone to the ethical hacking presentation. And I'm also going to do a brief introduction of the Voatz bug bounty program. There will be a longer demo tomorrow at 2 by 2 of my other colleagues. Quick bio, we've already been through that. And so for today, I'm gonna start off with going over why organizations would invite external ethical hackers to augment their security efforts, and also go over bug bounty programs. And I will also introduce the opportunity for you to participate in the Voatz bug bounty program. And that's going to include some background on our company and our mobile voting platform. Then I'm going to go through the ethical hacking process and how you can use those steps against the targets for this particular hacking objective, which is to try to find vulnerabilities in our test Android and iOS apps. And then I will have some additional resources that you can use during your ethical hacking endeavors. So to start off, and this is background information based on what I've seen in my previous roles. So organizations tend to have a lot of stuff, and a lot of that is arranged in things that are exposed to the public and things that tend to be more internal to the organization. So starting at the top with things that are exposed to the public include the products and services provided by the business or the organization. And this is really going to depend on the industry or sector you're in. And there are multiple industries. So there's the financial industry, the energy, transportation, communications industry. We'll see later that Voatz is in the elections industry. And depending on, again, the company or organization, there are going to be a variety of technologies that they may provide. In some cases, they provide professional services like consultants, and some of that's ethical hackers, pen testers, or just consultants to help you deploy and install and configure their products, and commercial off-the-shelf software that you can just buy from a store, for instance. Also exposed to the public, working our way down the organization's webpage. Most organizations today have some sort of web presence, web page, they're on social media. Also, some have customer and client-facing portals that allow external customers and clients to log into some application hosted by that business or organization. And some organizations also have web and mobile applications. Voatz, in this case, we do have a mobile application. And again, all of that tends to be the part that the public sees. Then you get more internal to the organization, and organizations have, and they are arranged differently. And there's usually, depending on the organization, they have some on-prem environment, and that's on-premise. So if I have a company and I have an office building, and I have network equipment, switches, routers, servers, and it is within my building that I own. That's what I mean when I say on-premise. There are also configurations where an organization may rent servers from a remote data center. There are companies that this is all they do. They have big buildings, they have a lot of servers that they rent out to customers. And then if I'm a company, in that case, I would have remote access into that data center. And I would be able to log in and make updates to those machines as if they were on my on-premise environment. Organizations may leverage cloud providers. And again, various network configurations. And then also, you'll often see organizations have their environments separated. So especially like if they're producing or developing some sort of software, there's a development environment that they use for all of their development activity. And then once you get to a mostly complete product, it moves to a staging or test environment. Again, those environments may be separate. They may be the same environment depending on the organization. That's where all of the testing goes on, functional and security testing. And then the actual production environment. And that's not, that environment is usually not the place where you do any type of testing. That's your final product. And then going even a layer deeper internal to the organization, you've got endpoints, and those are your employee machines. Those could be your laptops, those can be your mobile devices, servers, and on the servers, different operating systems, Windows, Linux. And then on top of that operating system, you may have various third-party applications. So a database or something hosting web services. And then you have your source code. And again, all of this tends to be internal to organization. And then organizations, and you'll notice in between each layer, I've got security. Organizations ideally like to set up their environment so that there's security throughout. So around the layers, within the layers, there's technical administrative controls that can include your intrusion detection systems, your anti-malware, your user account distribution, key management. And then for, again, depending on the organization, these may be very well documented, very strict, or a little looser, but I think a lot of organizations are moving towards documenting all of this as well, and then having policies and processes around all of this activity. So, challenges for an organization's internal security teams, given all of those different layers. There are thousands of known vulnerabilities and exploits available. And if you want to get an idea of how many there are, I've provided a couple of links here. There are other vulnerability databases as well. You can just do a Google search, but this is one that is commonly referenced. And you'll note that those vulnerabilities cover pretty much anything that exists within those layers that I just previously talked about. Additional challenges for an organization's internal security teams, just the number and variety of cyber attacks and threat actors. So we've heard a lot recently in the news about ransomware, malware, distributed denial of service attacks, and an advanced persistent threat. And the advanced persistent threats are usually characterized by they're extremely sophisticated. They have nothing but time on their hands. And they also tend to find their way into an environment and you don't know about it for up to a year. Data privacy requirements and regulations are something that from when I started out, it was part of the overall security requirements. And I don't know, you've heard the security triad: confidentiality, integrity, and availability. And the idea of protecting data fell well within that. But I feel like over the last 5 years or so, especially with the EU's GDPR requirements, that data privacy, in addition to security, has kind of been this separate extra protection bubble that is required. And that is something that also tends to fall with the security, with your internal security teams. And then you have your security tools, such as your intrusion detection systems, your anti-malware, things to capture packets that are on your network, and also your centralized log management solutions. And these are all great for internal security teams. Some of them do have some limitations in the sense that a lot of them are based on signatures and known indicators of compromise. So it will only catch what it recognized. And there are organizations out there that specialize in threat intelligence that monitor cyber attack, adversary activity, and they're able to attribute certain behaviors, certain IP addresses to a specific group. And then they're able to provide that information to the manufacturers of security tools to help inform security teams. That's great, but all of that automation means lots and lots of data to look through. So additional challenges for an organization's internal security teams. So if we go back and think about all of the vulnerabilities that can possibly exist, and there are many publicly available exploits, you can just do a Google search for those as well. Scanning your network for vulnerabilities using a vulnerability scanner is ideal. You want to identify which systems may have outdated operating systems or outdated software. However, those scanners can negatively impact critical business applications and systems. In one role I was in, I was responsible for vulnerability management. The vulnerability scanner that I was using was effective. We got a new director of the IT department, and we had to coordinate in order to get that person's go-ahead, because in that person's previous role, that vulnerability scan had taken down some of his systems. And then additionally, security patches, those are released as industry finds vulnerabilities in its products. And they must be tested, and they need to be tested usually in the test environment before they can be pushed to production. But again, they have to be tested because occasionally patches do break a system. And again, depending on the industry, depending on what function within that industry or within your company, it may have a very low tolerance for interruption and downtime. I've seen organizations that still are running Windows 98, Windows 2000 machines, right? Those are out of date, and they are not that they're very sensitive. So, trying to make any changes, even security-wise, would have a negative impact. And so, I've been at companies where there's multiple people I have to coordinate with in order to apply a security patch or to make a change to a system. So the actual box and the operating system itself would fall under, for instance, the IT department. And then an actual application running on that box or database would be a completely different person. And then some organizations have a change control board, which is a group of stakeholders, representatives from a variety of departments within your organization, who meet on a regular basis to look at the changes, determine if downtime is required, approve the changes, and that can take anywhere from maybe 48 hours for a critical change or a critical patch to 2 weeks. And then in the case of web and mobile application development, ideally that's one of those things where you've got security built in from the front end, in the design and in the requirements process in the early stages of that. And you'll see some of the, like the change management and some of the processes and procedures that they're still there. They may be accelerated, but they're still managed and they're still documented. And developers still have to work towards doing secure code practices. And sometimes security teams are also responsible for doing code reviews, looking specifically not just for like vulnerabilities that can be discovered from a scan, but actual vulnerabilities within the logic. So given all of that, that's a lot for a security team. And then in addition to that, a lot of companies have a very small security team. I worked in a company that we had at least a couple of thousand servers, both within the United States and overseas, and there was like 4 of us. So, so there are a number of considerations when an organization is trying to figure out, well, how do we best implement security across all those levels that I talked about earlier. Also, so that's a lot of work, and then time, right? And then the number and varieties of attacks and threats that must be defended against. I don't know who said it first, but it's often repeated in the security industry. The attackers only have to be right once. The defenders, we have to get it right more all the time. So another consideration that companies and organizations think about is how do they demonstrate that they're doing the right thing security-wise to their customers, clients, and users. So it's one thing to have your internal processes and practices and trying to do security through all those levels, but how do you actually prove to external entities that you're doing that correctly? And one of the ways that organizations do that is to bring on external independent auditors. And there are organizations or companies that they specialize in auditing organizations for security. And they'll take an objective look, and they can even provide some type of certificate for your program that says your company is secure based on this criteria. And that usually has to be redone periodically. So it could be months or every year or so. So given all of that, how would an organization then reach a wider audience with additional security expertise? So there's several approaches. One is to formally hire external pen testers or ethical hackers, and doing that process usually requires some sort of formal agreement. And formal agreements, it's like a contract, and it usually outlines the rules of engagement, a scope of an organization's systems, again, thinking back to all those levels that those pen testers or hackers are allowed to access, and also processes for how they handle and report their findings. And I just want to add a note about written permission. It's commonly said in industry that you need written permission before you touch a network. And the first course that I took in college that kind of, put the idea in my mind that this is the type of work that I wanted to do, I think it was called the Ethical Use of Computers. And from that course, all the way through all of my other education, all of the other training and continuous education, I was doing a web application hacking course about a month ago, but the common refrain is, if you don't own a system, leave it alone. So I just want to, that's the advice that's been passed on to me. So I pass that advice on to you. But that leads me to the next point. Another way organizations do bring on external hackers to where they can, that does serve as written permission. They organize hacking events or hacking challenges, very similar to this hackathon. And then another approach is also to start a bug bounty program. And that is what we've done at Voatz. We're not the only organization to ever do that. It is, lots of organizations have done this. But so the hacking objective for this hackathon is to introduce our bug bounty program and to invite you to participate in it. So what is Voatz? And I have, so I'm going to talk about the ethical hacking process a few slides later on, but just want to make a note. One of the first stages of that process is information gathering. Sometimes it's called footprinting, sometimes it's called recon. But when you are doing an ethical hack, a good first step is to learn everything you can about your target. So in this case, it's Voatz. And to provide context and information about Voatz, what do we do? Voatz, our mobile elections platform, enables citizens to vote using their smartphones. So we have an Android app and an iOS app. For these elections, we work closely with clients to integrate our smartphone app-based technology with existing elections operations to facilitate the voting process. So again, information gathering, there's our website, it's publicly available information. Anyone can access it, lots of good information. And again, thinking about just the overall ethical hacking process, not just for today, but if this is something you want to do, organization's website is a good place to start. We do government and non-governmental elections. And also, for added context, election systems are designated by the Department of Homeland Security as critical infrastructure. There's some information on that link, and this is important because the security principles across industries may be the same, but there may be different aspects to that particular organization and the sector, for instance, that they may be working in that you have to consider while you're doing your ethical hack. So we have the elections, there's the financial sector, there's the energy sector, there's the transportation sector. So all of those are going to have different considerations. So for instance, for finance, you're processing payment, right? So Voatz at this time, we're not processing any payments. And then also another thing you want to think about while you're doing an ethical hack, here's a link to our disclosure policy. So back to when organizations hire pen testers or ethical hackers, and there's usually this contract, this scope of work. Part of that is we'll tell you how to handle a situation where you're proceeding in your hack and perhaps you come across sensitive information stored somewhere where it shouldn't be. Everyone makes mistakes, and the whole point of doing the hack is to discover that type of thing. But as an ethical hacker, you're responsible for protecting that information when you discover it. And reading things like the disclosure policy, the contracts you sign, or the rules of engagement for an ethical hack, again, not just for Voatz, for any organization, is very important. So continuing on the theme of information gathering, so your hacking objective is to find bugs or vulnerabilities in our test versions of the app. And we've created a landing page. Please just use that link and that will take you to the apps that you can analyze. So a high-level overview of the mobile voting process, understanding how the process works may give you some information about how to conduct your ethical hack and where to start looking around. So a voter is eligible. Then the voter downloads the iOS or the Android app. The voter goes through some sort of registration process using the app, and they verify their identity. Then the voter receives the ballot on their mobile device when the polls open. The voter then votes using their smartphone. They would get an email receipt, and that email contains additional information that can be used, for instance, during a post-election audit. So now, how does all of that work into the ethical hacking process? Again, ethical hacking done with written authorization. And also, I've listed the steps here, and these map closely to the way an attacker, a malicious attacker, would perhaps go about hacking into a system. But the steps can actually be performed in any order as dictated by whatever your hacking objective is. Additionally, you can do them in order, and then you can get, for instance, you can do some recon, scan, get some more information, and then gain access to one particular device or server on a network, and then realize you can't go any further. Then you might have to go back and do additional recon or do additional scans, right? So I've listed it here kind of in general steps as they are commonly named. They may have different terms, but this is generally a good idea of the things that you have to go through in order to complete a successful hack. So recon, so we've done a little bit of that about Voatz. So you're gathering open source information about the target. And this is something that is open to the world, right? You don't need permission to go search Google. Companies, they have they put a lot of information on their website. You can find their address, you can find office locations. A lot of companies have social media presence, job searches. And this is one thing I didn't think about. I remember when I was initially going through some of the early training. You don't think about it, but when an organization lists the requirements for jobs, for instance, like a senior Perl developer, that gives you a lot of information of what type of technologies are in the target environment, right? And then that gives you an idea of what type of vulnerabilities to search for in that public vulnerability database to see if they work against that target. Also, for recon, I'll talk a little bit about phishing at the gain access point, but that's the type of information that phishing and phishers use to craft their emails to make them look very realistic, and also to target organizations. And so as an ethical hacker working inside an organization, one of the things I like to point out for a company is don't put so much information on our website or in our job descriptions, but sometimes there's a balance to be struck there. So next step, scanning and enumeration. This is the step, I mentioned several times, hacking done with written authorization. This is the step where sometimes you are crossing over from just kind of doing what's available publicly to actually touching an organization's network. So this is where you are trying to gather specific information directly from target infrastructure. So you're looking for live hosts, IP addresses. Depending on the type of scans you're running, you can discover what type of operating systems are on the network or on those hosts. You can also discover what type of ports and services are being used, especially those that allow for remote access. So if you're looking for ways into a system, ideally, again, if you're an ethical hacker and you're working for an organization, you want to tell organizations to disable any ports and services they're not currently using. And a lot of times the remote services are not ones that a server needs open in order to function. Also, this is the step where you're going to start to identify vulnerabilities in the operating system or third-party applications. Again, thinking about this hacking objective, are there vulnerabilities in iOS and Android devices? So the next step, gaining access. And this is where you're actually compromising and exploiting the target. And this step is often based on information that you've learned in the previous steps, right? So you've identified vulnerabilities and there are exploits. Again, some of them are freely available. There are, you can write your own in some cases. And you'll use information from previous vulnerabilities that you've discovered to do that. So phishing, and I have that under gaining access because in the news, there's been a lot, I've heard lately, ransomware has been a growing problem. And a lot of that has not been because the attackers have done some spectacular hack. They've been sending malicious emails that look very realistic based on their recon with malicious attachments or links that they're tricking users into opening. And that's the way they're able to gain access completely behind your firewall, inside your environment, and again, without even having to do any type of scanning or enumeration or looking for vulnerabilities on your network. And then some of the other things, gaining access to source code. I mentioned in the slide with the different level source code, some organizations have their source code wide open, freely available for everyone, others do not. But gaining access to source code is one way that you can also look for and exploit vulnerabilities from an organization. Maintaining access, and I have a special note there about advanced persistent threat. Again, those are usually organizations that are well-funded, well-resourced, often nation state. And one of their key characteristics is hiding in a target environment for an extended period of time without getting caught, and then moving laterally within the environment. So jumping server to server and behind the scenes, and then what people usually catch is when data is leaving the network. So maintaining access to your target and establishing persistence in their environment and not getting caught is one of the steps, again, of the ethical hacking process. And again, we're getting into really why you work with the organization and obtain written permission before you do these types of things. And then lastly, covering your tracks. And so this is where you are trying to see how effectively you can do the previous steps without getting caught and without getting seen and without setting off any alerts on the security tools. Deleting logs, deleting browsing history, of course, if a lot of security tools are smart enough to know that logs should be there, and if they're gone, then there's a problem. And then encoding commands and traffic to bypass monitoring alerts. Again, security tools are getting very smart to where they're able to detect that. But just again, if you're doing an ethical hack, this is one of the ways that you can see how effective an organization's security is. So how do we take all of that and apply that to a mobile app? So thinking about some of the threats facing smartphones and mobile apps. So according to this link, the article at this link, by 2025, 72.6% of internet users will access the web solely by their smartphone. So that means that there's going to be a lot of targets and a lot of data that could be potentially exposed or lost. There's a lot of data stored on smartphones, and that's data stored by users, stored by the apps, data in transit, and it coming to and from the device, right? And all of those, and that's just a subset of the information: phone calls, voicemail, your contacts, text messages, email, photos, your payment account information, stored passwords. And for mobile devices, smartphones, spyware keyloggers and other malicious apps can capture, can read, and can potentially exfiltrate all of that information from a mobile device. Phishing is also a threat to a smartphone, since if we're getting our email on smartphone, we can still get those malicious attachments and malicious links, and those can also be sent to text via SMS. Another thing to think about: insecure Wi-Fi. Mobile devices connect to wireless networks, cellular, Bluetooth. Same threats posed by our laptops connecting to insecure Wi-Fi affect smartphones. And then also vulnerabilities in the operating system. And in our case, it'll be Android or iOS. So a couple of more hints for this particular hacking objective for our Voatz bug bounty program. And again, landing page is there. So thinking about the test apps, thinking about how an app is built. So I had no experience with mobile applications prior to joining Voatz, and that's a little bit over a year ago, but understanding, I'm more comfortable with Android, but understanding how to actually build an Android app and generate that APK helps to identify places where you might need to look a little closer for security. Also understanding the protections, what protections organizations can implement that you discover, right? So back to the industry, if you are, we're in the elections industry, and then, thinking about banking industry, the apps used in those industries come with some protections built in. And so one of the things to think about is what types of protections can you build a mobile app with? And then is there a way to work around those protections? Also, understanding how the mobile app works. At the site and that landing page, you'll be able to download the app and actually go through and see what type of functionality comes with it, what a user is able to do with the app. That will help you identify places where there might be, where you might want to look for security issues. Source code. And then how do users interact with the app? So then thinking about the device itself. So, again, previous to this role, I've worked primarily with laptops, desktops, and servers. Mobile devices, they're computers, but they're a little bit different. So what type of security is built into the device? Does it matter if the device is rooted or jailbroken? And what vulnerabilities are in the operating system? And then at the network level, are you able to discover what type of, which IP addresses the app maybe communicates with? How does the app communicate over the network? Is there a way that you can see the traffic leaving the device, and what type of traffic? Is it in clear text, or is it encrypted or obfuscated in some manner? And then also think about, maybe you're not gonna find something in one step. So even if you do see one thing that maybe it's like, this doesn't seem right, quite right, and you give it a try, and then it's like, oh, okay, well, I don't get anything out of that. Can you string together several steps to see if you can find a bug or a vulnerability? So here are some additional resources. The first on ethical hacking. So EC Council provides the ethical hacking certification. Is the one that I have, but they've got a lot of good information on ethical hacking if you're really interested in learning more. So the next one, finding devices connected to the internet. Again, this is freely available information, not saying it's necessarily applicable to this particular hack, but it is a site, it's a free service, and it is kind of cool to poke around on. Information about malicious or non-malicious IP addresses, domain URL, and file hashes. So VirusTotal, again, another free site. And so one use case is you're an analyst and you're watching traffic leaving your network and coming in your network, and you see source or destination IPs that you're like, this doesn't seem like something that within our organization we should be communicating with. You can take that IP address, you can take any IP address, put it in VirusTotal's interface, and it will provide you information on if that IP address is associated with non-malicious activity. And I will stipulate that, again, there may be some lag time, nothing's instantaneous. So just because it doesn't come back initially as malicious doesn't mean it's not malicious. But it is a good resource and a good starting place for understanding some of the traffic that's on your network. And then also, again, vulnerability database. Again, do a Google search. There are multiple databases out there. This is just one of them. So wrapping up, a couple of takeaways. Again, Voatz Bug Bounty Program demo is tomorrow at 2 o'clock. Links to the beta versions for hacking. There's one for Apple or iOS and one for Android. No hacking on the live Voatz environment. So we do have multiple versions of the app. Please follow the links in the presentation. If you go directly to the Google Play Store or the Apple Store and search for Voatz, you'll see the live version of the apps, which is off limits. So please don't do that. So use the links provided in this presentation. Read the disclosure policy. A lot of times when we download software or something, there's like a long terms and conditions and user agreement, and we don't often like to read those. This is not something you want to skip over. This is not something you want to not read. So please read that. And again, this goes for not just if you're doing this bug bounty program, this goes for any ethical hack that you are interested in participating in or bug bounty program. Read the disclosure policy, read whatever the documentation and guidelines they provide. And again, the hacking objective is to test versions of the Voatz Android and iOS apps. So help us discover vulnerabilities and weaknesses so we can fix those issues before some malicious hacker exploits them. And yes, you are on the test version of the apps, but if we can find issues at the test stage, that'll help us create a more secure production app. And with that, I think there may be questions or may have time for questions, but that wraps up my presentation.
Yeah, awesome. Thank you so much, Nailah. Everyone, that was a really awesome discussion on Voatz. So there is if everyone wants to go to the event Q&A section on Discord, you can drop any questions you have there, and I will be able to answer some of them. I can get started with a first question. Nailah, can people access some of the links that were mentioned in your presentation through maybe the Voatz channel on Discord?
Oh, yeah, I can upload those. Yep.
Awesome, that would be fantastic. Yeah, and I guess another follow-up interesting question: where do you think the future of mobile election voting is going, or mobile security in general?
So mobile security is, I think there is a lot, I think there's a lot to learn about it. And that's just my impression over the last year that I've been working with it. I feel like that a lot of folks are very comfortable with security of laptops, security of desktops, security of servers, Linux, Windows security. But when it comes to mobile security and understanding, because it's actually, I find it very fascinating. There's some security features built into the actual mobile device that you don't find on a laptop. And understanding that, oh, well, this would be a problem on a laptop, but then you've got a security device and you read up on it, like, or I'm sorry, a mobile device, and you read up on a similar type of threat, and they're like, no, you can't do that, or not that you can't do that, right? There's, nothing's unhackable, but it's different. So I think I would say that my impression is that there is a lot to learn about mobile device security. And I haven't even touched tablets, right? So I primarily focused on an Android smartphone. So I've done a little bit of iOS phone, but you're talking tablets as well. So I think there's a lot of growth to be had there.
That sounds really interesting. Yeah. Fantastic. So we have two questions. I think we have some time for two questions. Yeah. So first off, Preston asks, are there technologies that you found to be more vulnerable than others? Are there differences between languages and platforms, or is it mostly an issue with libraries used in development?
Ooh, it can be a mix of all of the above. I will say, yes, it seems Android does have more security issues, and that's not just me saying that, that's also based on research, than iOS. And again, I'm not quite as familiar with iOS, but from what I've seen, it seems that they've just, their architecture, they have built in far more stringent security controls for their user environment. As far as languages go, I don't know that I've seen anything with language libraries. I can check with our developers. They work a little closer with the Kotlin and the Swift languages, and I can see if they notice any difference in the libraries. But one thing that I know we try to do, and some organizations try to do, is to limit their external third-party libraries just for that reason. So trying to keep as much in-house as possible.
Interesting, yeah. Another question, Tetradium asks, what is the future of security for smart devices like watches, or even IoT things like smart cars and HomePod?
Ooh, security future? So I don't work a whole lot with those. I actually prefer to try not to have, try not to do too much with that, or at least in my day-to-day life, unless I really see something I want to experiment with. But I would say those have a long way to go. That Shodan link that I provided, I don't know if it's gotten any better, but at least within the last 2 years, one of the big deals were that you could use that site and find all kinds of IoTs connected, publicly available, connected to the network. And I think one of the key problems is some of those come with default passwords, default out-of-the-box manufacturer passwords that people don't change. And I don't know if they know if the average user knows that they need to change that. And then of course, if you're changing passwords, you're into password complexity. And so I think those have a long way to go security-wise. And in that case, for us security professionals, that's a great opportunity to kind of branch into, to explore, well, how do we secure these devices if they're going to be out there on the internet?
Awesome, great. Yeah, okay, I'll read this follow-up from Preston then. I think we have enough time for that. So Preston follows up with, one thing that I've heard is the diversity of Android is actually a boon to the point where iOS hacks prices have gone significantly down.
Can you repeat that?
I think it's, so one thing that I've heard is the diversity of Android is actually a boon to the point where I think this is the price on hacking iOS hack prices have gone significantly down. And there's a link in the Discord. There's a link to an article um, from Wired in the event Q&A channel on Discord. I don't know if you can check it. I can post a link here as well.
Okay, yeah, I can, I'll take a look at that. And so it sounds like what that is getting at is that because Android is so different and there's so many varieties of Android that it makes it more difficult to hack than it does to just try to hack iOS. Is that what they're getting at? If that's the case,
Maybe.
okay, I'll have to read the article. It sounds like if they're talking about cost as far as is it worth it to try to hack Android and what can you gain? Yeah.
Awesome. Well, thank you so much, Nailah, for taking the time to talk with us today. If anybody has any other questions, definitely check out Voatz and the sponsor booth. And I think Nailah will also be able to drop the PowerPoint and all the links there as well. But yeah, thank you, Nailah, and thanks for everyone for coming.
Okay, thanks for having me.